All right, we're going to start the 6.2 lesson with just a quick review of 6.1. And remember, we are dealing with this standard form of a parabola, ax squared plus bx plus c. We know that this a value tells us if it opens up, positive, opens down, negative. The axis of symmetry, which also gives us the vertex point through substitution, can be found from that b value and our a value again. Our y-intercept value, where it crosses the y-axis, comes from our constant value. And so that's just a quick recap because we are going to be graphing these quadratic equations. In this case, we're talking about solving them. And when we say solving, what we're really after is where does it cross the x-axis. That is what we talk about when we want a solution, is where is it crossing this axis, because those are the ordered pairs some number 0 that we are most interested in. Now, three things can happen with a quadratic, and let's just take a blank page to look at this for a minute. If you think about how a quadratic can interact on a graph, it can come down and it can cross in two spots. And that would be true for an open up or an open down. It can come up and touch in exactly one spot and go back up or go back down. So in this case, you have two real solutions. In this case, you have one real solution. And then the third option is that your parabola, either open up or open down, might never cross the x-axis. And what happens here is no real solution. And this is where our imaginary numbers come into play. So when we go to look at a graph, we don't know what's going to happen. So finding that axis of symmetry and determining our vertex and open up and open down are very critical to know what we're looking for. So the first thing, two real solutions, it's going to cross twice, 2 times. So first thing we always look for is that vertex and that line of symmetry. And remember, we get that by the opposite of b all over 2a. So here's my function. And when I look at my values, a is 1, b is -3, and c is -4. So my vertex point is the opposite of b all over 2 times a. So I have positive 3 over 2. So somewhere about 1.5 I'm going to have my vertex point. Now, I also know that this is open up. So depending on where that vertex is, I will have 1, 0, or 2 solutions. So let's go ahead and make our chart. And the first point I'm going to try is my vertex, because I want to know where that is. And if I put my vertex in here, 1.5 squared minus 3 times 1.5 minus 4, I get -6.25. So this is -6. My vertex is right there. I still don't know exactly where this is going to cross, but I know at this point, because it's open up, this thing is going to be continuing some direction that way, some direction that way. It's going to cross twice. Now I need to go try to find those crossing points. So I'm just going to start with some values on either side. So I'm going to start with 0. I'm going to let x equal 0. And 0 squared minus 3 times 0 minus 4 is -4. And that gives me that y-intercept point. 1, 2, 3, 4. Now that also means that over here is that intercept line of symmetry point. So I have to keep going outward. So let's try -2 to see if we can find the point. So I have -2 squared minus 3 times -2 minus 4. And when I do that math, I have 4 plus 6, which is 10, minus 4 ends up being positive 6. So at -2, 1, 2, 3, 4, 5, 6. My parabola is going to be clear up there. So that means also that over on this side, I'm going to have a point 1, 2, 3, 1, 2, right there. And so I can go ahead and graph my parabola. Now somewhere between 0 and -2, I should probably plot another point. So I'm going to pick -1 because I want to know exactly where I'm going to cross that axis if possible. So -1 squared minus 3 times -1 minus 4, and there's my point. -1, 0. There's one of my solutions. And you can see where my graph is an estimation. Now that means that I should also be checking at 1, 2, at 4. I should be checking also. So let's check at 4. 4 squared minus 3 times 4 minus 4 is also 0. And so my solutions are at -1, 0, and 4, 0. Two real solutions where it crosses the x-axis. Now, if I'm in one of those situations where there's only one real solution, crosses one time, that means the vertex is going to touch that axis. So let's go ahead and look at our starting equation. Here it is right here, but we have a problem. It's not in standard form. So I need to add 4 to both sides to get x squared minus 4x plus 4 equals 0. So now I know a is 1, so it's an open up. I know that b is -4, and I know that c is 4. That means that's my y-intercept. So I can go ahead at 0, 1, 2, 3, 4, plot that point. So let's go ahead and find our line of symmetry, the opposite of -4, all over 2 times a, positive 4 over 2, which is 2. So somewhere along this line is my vertex. Well, I also know I'm going to have a point over here. Let's go ahead and put our vertex point in because I'm giving you a clue that there's one real solution. But I think it's always good to start with the vertex. 2 squared minus 4 times 2 plus 4. So 4 minus 8 is minus 4 plus 4 equals 0. So at 2, 0, the thing opens up. And so this is my one solution, and it is at 2, 0. If we're looking for no real solutions, and this is, it's never going to cross, we're going to go through the same thing, except this time you have to write the equation. Two real numbers whose sum is 4, whose product is 5. So I need to let x and y be real numbers. So the first part, whose sum is 4, so x plus 4 plus y equals 4, whose product is 5, x times y is 5. Well, I don't know how to graph things with two variables, so I'm going to go ahead and solve this one for y, and then I'm going to use substitution, And I'm going to say, well, wherever there's a y, I'm going to replace it. And so I'm going to have x times 4 minus x equals 5. Do your distributive property, 4x minus x squared equals 5. Put it in standard form. I don't like a negative x, so I'm going to move everything to the right. Negative exponent or negative coefficients on my x squared always make me nervous. So I have 0 is equal to x squared minus 4x plus 5. Now this is something that I can graph, and it's something that I can work with. So what do I know at this point? I know that this is open up, and I know that the y-intercept is at 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now where is my line of symmetry? Well, the opposite of b all over 2 times a. So I'm looking at 2 again, somewhere on this line right here. So let's go ahead. That means there's a point right over there. Let's go ahead and find that vertex point. And so I do that by substituting 2 in for x. So I have 2 squared minus 4 times 2 plus 5. And I have 4 minus 8 plus 5. And so I end up with 1. So at 2, 1 is my vertex. And because it's open up, you can see it never crosses. And that's why we say, therefore, no real solution. Now we're going to go ahead and tackle an estimate and a word problem in part 2 of this video.